Nice to meet you all. My name is Oisín. I'm CTO and co-founder at Obal Labs.
And my name is Richard, head of business. And today we're going to be talking about our personal favorite topic, which is distributed validator technology. So quick show of hands, who here has actually heard of distributed validator technology? Okay, a few. And who thinks that they would be able to actually describe it in 1 to 2 sentences concisely? Jim, my guy. All right, we got a lot of education to do, but it's going to be fun. So today we're going to be talking about the viability of a super robust Ethereum and how DVT actually plays into that idea of a robust world computer. So who is Obal Labs? Obal Labs is the R&D team that is focused on building technologies for credibly neutral, trust-minimized infrastructure for Web3, and specifically today, Ethereum. We are the first core development team, but the idea is that in the future, we will actually have multiple developer teams building multiple implementations of Obal distributed validator technology. And we are supported by the best. We're very lucky to have had a massive ecosystem of big players, strong capital providers in the space, as well as some of the most prominent validators and node operators in the Ethereum ecosystem that are very focused on supporting the Obal team towards building the optimal implementation of DVT, and furthermore, also helping us drive its adoption for the betterment of the entire Ethereum ecosystem. And also, just really quickly, wanted to thank the 7X team for having us here, and we're also very excited to be bringing them on as investors as well. So, thanks guys. So, what makes for a solid foundation of Ethereum? Where are we at today, and what characteristics do we really want to see further accentuated to make Ethereum the global settlement layer that we know it can be? So first and foremost, we want extremely high percentage of Ethereum staked to the beacon chain in order to increase economic security, right? That's all a proof of stake consensus really is at the end of the day. Economic-based security, the more economics that are staked at the consensus layer, the more robust the security. Pretty straightforward. Secondly, we want it to be trustworthy, right? So what does that mean, right? Everything works. Blocks are built, blocks are finalized, continue to finalize over time, resilient against any sort of attack vectors at the consensus layer, so it needs to be reliable and trustworthy. Next, it needs to be inclusive, right? So if this really is the global settlement layer that we know it can be, we want it to be highly participatory from a wide array of participants that are distributed all over the world. But it's actually not just about a geo-distribution, it's also the type of actors that we want involved in securing this global settlement layer. So that means it's not just large validator entities, it's also small validator entities, it's really any sort of organizations around the world, big and small, but really more importantly, it's actually about individuals from all over the world empowered to participate in that global settlement layer and securing it therein. So how are we doing so far? What is the state of this global settlement layer that we call Ethereum today? At this point in time, stake participation has grown significantly, and we are very excited about that. I think before withdrawals, it was maybe 12, 13%, and now we're actually at more than 20% of the total supply of Ethereum staked to the beacon chain. So we're growing very quickly, and we anticipate that number to only continue growing. But it's actually not enough. We would like that number to be significantly higher, just because, again, if you think about proof of stake as economic-based consensus, that number needs to be higher to secure that global settlement layer. But we're doing a good job so far and anticipate us to continue doing a good job now into the future. However, solo participation, solo staker participation specifically, people that are running machines at home, grossly underrepresented in this distributed economy. We estimate that anywhere between 6 to 8% of validators are controlled by at-home stakers. Per rated, it's 6.5%, but those numbers are very hard to get concretely, so anywhere between 6 to 8%. The vast majority of these validators are also based in Europe and in the United States. That needs to be more distributed in order for Ethereum to really manifest its destiny as that global settlement layer. And we've seen recently, a couple months ago, that the Ethereum network was actually having difficulty finalizing blocks. It was still producing blocks, no problem, but finality was called into question. So again, referring to that resilience that's so required to make Ethereum really this global settlement layer. So where does OBOL and our DVT implementation fit into that picture? I'll kick it over to you, Oisín.
Sweet. Thank you very much, Richard. So, as we alluded to, this talk is about new trends in staking, well, new trends in crypto more broadly, and we want to talk a bit about distributed validators. So, for those of you that aren't familiar with what a distributed validator is, a distributed validator is an Ethereum validator that runs on multiple machines with software-based fault tolerance. Think of it like a multi-sig, but for a validator, where you only need 3 of the 4 nodes to be online and working correctly for your validator to stay online. This is a super powerful piece of software, and it's something that we think will change staking for the better for lots of different parties all over Ethereum. To give you an idea as to the different types of actors that can benefit from distributed validators, I want to talk through them now. So the first one are the staking products. These are the liquid staking protocols and the likes. These people gather up a lot of Ether and want to stake it with node operators, but these node operators at the moment have kind of total control over certain amounts of these stake. Certain entities in Lido have about $500 million or more of stake that they're responsible for. What a liquid staking protocol would prefer to do would be to have that stake being shared by a group of entities rather than one single entity having total control over it. This reduces the risk of slashing, it reduces the risk of them going offline, and generally makes the liquid staking protocols more resilient to bad actors. On the professional operator front, so the centralized node operators that run stake for enterprise clients, these people can also benefit from distributed validators, but don't necessarily use it for the idea of multi-operator validation. For a professional operator, you use a distributed validator for high uptime. You can put your validator across multiple machines, generally lower cost, more performant bare metal ones than something that runs in the cloud. And when machines die, which happens all of the time, no big deal. Your validator stays online, you fix the broken machine during working hours, and everything runs smoothly and you have no downtime. This is something that is a very common technology in Web 2. Google doesn't go offline when they update their version or when a machine dies, neither should Ethereum validators. On the home staking front, home stakers are obviously very keen to get involved in Ethereum staking, but 32 Ether is now prohibitively high for almost every home staker. And with distributed validators, you can enable the idea of squad staking. Squad staking is the idea that you can team up with other people around the world, share your Ether, and stake together in a group. This, again, brings all the same benefits of resiliency, trust minimization, and allows a home staker to have the uptime performance that a professional enterprise might have currently. And last but not least, one of the real benefactors of distributed validators is the Ethereum network itself. If the Ethereum network has more parties that are validating as groups rather than individuals, these people are validating for multiple geographies, multiple jurisdictions. This all adds together to make validators more resilient, more immutable, and less likely to harm the network. That's kind of some of the main upsides of distributed validators. So if they're all the upsides, where are distributed validators on their journey at the moment? Distributed validators as a concept have been around since 2019 in DevCon when they were first presented by the Ethereum Foundation. And at this point in time, we're running on mainnet since the end of last year. We have 40 node operators running in production at this point in our alpha phase. We're working on a mainnet MVP with Lido to bring distributed validators into Lido, hopefully early in the new year. We've been doing large-scale testnets with our community, including having 1,600 girly validators running DVs with operators from all over the world. We have solo stakers actually running mainnet validators in liquid staking protocols with EtherFi as of a month or 2 ago. This is growing quite rapidly, and it's great to see that we can get these solo stakers that wouldn't be able to run or wouldn't have the capital requirements to do so, to be able to get involved and to decentralize these liquid staking protocols and to make them more resilient. On the performance testing side, we recently did a performance test with the Miga Labs team out of the Barcelona Supercomputer Center. They ran 3,000 girly validators on 4 bare metal machines, proving that you can have high uptime, resilience, and extremely low cost versus kind of cloud-based deployments that current enterprises use. And last but not least, we've also completed a security assessment with Sigma Prime early in the year, and we're doing a lot of ongoing work on auditing and penetration testing our Solidity, our front end, our client, and all of those good things. To talk a little bit about how these distributed validators actually work, I want to kind of dig into the technicals a little. So BLS signatures do something interesting that hasn't really been done before, which is you can add signatures together without access to the private keys. What's important about this is it allows distributed validators to be a simple middleware that sits between a validator client and its consensus client, and it does two things. It comes to consensus on what every validator will sign, and once every validator signs the exact same thing and returns the signature, these middlewares aggregate the signature into like a group signature and send it upwards to the network. What's nice about this is the client doesn't need anyone to change their private key infrastructure. They can keep their existing stack and they just add in one simple middleware that works like a little proxy, and that allows them to gain the benefits of distributed validators. Another important aspect of it is the distributed key generation. At the moment, with the centralized validator, one entity and often a couple humans in that company have access to all of the private keys. And if they click on a dodgy PDF or something of the sort, even Vitalik can get hacked, somebody can get access to all of the private keys for a validator. That is an extremely scary situation, especially at scale, because slashing scales non-linearly. The mitigation for that is to do a distributed key generation rather than to create the keys separately or to get centrally. That means that all of the entities running the distributed validator have a piece of the key, but no one entity has all of it. So you have to compromise many, many people to get the full private key to be able to slash them. The last thing I will say is that these distributed validators use consensus, so you generally need more than 2/3 of nodes to be online and honest. That means in a 4-node cluster, you can have 1 offline. In a 7-node cluster, you can have 2 offline. In a 10-node cluster, you can have 3 offline. And despite that, they'll all stay up and online and healthy in the testing. So why should you care? Is this important or not? Is this a new trend? Vitalik has had distributed validators on his roadmap for Ethereum since about 2020, and it's one of the remaining items on the merge section. And if Vitalik cares, I think you should care too, to be perfectly honest. And as I alluded to before, Ethereum will be more decentralized and more resilient if people stake as groups rather than as individuals. And that's kind of what I'm here to convince you today of. Last but not least, how might you get involved in this if you've been your interest has been piqued? We have a Discord community. We would encourage you to run a distributed validator on Gurley or on mainnet if you're feeling brave. Please get in touch with us if you'd like to get involved. The QR code here is a link to our link tree, which has links to our Discord, to our Launchpad, our doc site, and most importantly, we're hiring. We're hiring Golang researchers, community organizers. We have quite a number of open roles, so if you're in the space and you like the idea of working to decentralize Ethereum, I'd highly recommend you throw in an application and have a chat with our team. Other than that, thank you very much for listening, and I think that's about it. I don't think there's questions today. See you now.
Thanks, guys.